Hello everyone and welcome back to your YouTube channel and welcome to this very short but very important video today. As you must be aware, I am recording those videos because some of my students are taking this course that is an introduction about data science or data analytic for smart grid. And a very important aspect is the proper modeling of the energy system. So today we have here a very simple problem, numerical problem that is related to calculating the energy independence and the self-consumption ratio. Those are two very well-known indicators when you have an installation. For instance, you have a domestic solar PV system and you want to understand how the generation profile is matching or not the power demand. So without further delay, let's read this very interesting statement over here. Measurements of the mean power output from a domestic solar PV installation and the domestic demand has been made at 1 minute resolution. And here in this table that I am showing here, you can see the first column is for the power demand and the second column is related to the output of the domestic solar PV installation, or simply the output power. Okay, now we want to calculate those two important indicators: energy independence and self-consumption ratio. So the first step over here is that we need to define the time. We need to define here the input data. We know the power demand. We know the power generation. Time is not relevant for this calculation, so we are creating a vector for the first column, and that is the power demand, and a vector for the second column with all the numerical values for the power generation. So the first calculation is to obtain the total demand. For that, what we are doing is summing or adding all the power demands. That is equivalent to adding every single of those elements on the first column. So as you can see over here, the total demand over the period is 17.13 kilowatts. Similarly, we can calculate the total generation. To calculate the total generation, again, what we are doing is adding all the individual values of the power generation during the period. So you can see is equivalent to adding all the single measurements in this column. So now adding that, we obtain that the total generation is 9.98 kilowatts. So from here, as you can see over these measurements, you can see that the total demand is larger than the total generation. So the next step is to calculate one important indicator, that is the total generation consumed locally. That means we want to know the specific proportion of the power that is remaining after the power consumption. So what we need to do is, for each one of those rows, for each one of those measurements on 1 minute resolution, we are calculating which one is the minimum between the demand and the generation. For instance, here in the first column, we have a power demand that is 2.85, and we have a power generation that is 0.31. So for that reason, the minimum value is 0.31, and that represent the total generation consumed locally. So using this equation that I say, the minimum between the demand generation and the generation, the power demand and the power generation, we obtain that the total generation consumed locally is 9.51 kilowatts. Now it's time to calculate those indicators, the energy independence first, and second, the self-consumption ratio. The energy independence is a very simple quotient here. On the numerator, we will use the generation consumed locally, and here in the denominator, we are using the total demand. So as you can see, we are dividing here the total generation, 9.51 kilowatts, and the denominator is 17.13. So we obtain energy independence of 55.52%. Then the next step is calculating the self-consumption ratio. Again, we are using the total local consumption, 9.51, divided by the total generation, 9.98. And as you can see over here, the self-consumption ratio is a very important indicator because this is telling you that 95% of the generation coming from the solar PV panel is used to cover the local demand. So, well, this is the end of this video. Thank you very much for watching, and I will see you at the next one, and it's time to say to you, bye now.